Okay, so in today's video, we're going to do problem 75, sort colors. It is a medium problem, but sometimes even medium problems can become very simple, and even easy problems can become a little bit complex, and you're like, why is this even an easy? For me, this is like, why is this even a medium? So basically, it says that we want to sort an array of nums in place so that the numbers are adjacent. Now it says colors. They're just adding words to make the problem a little bit different. But basically, they're just using three numbers. Okay, so they're going to be using 1, 2, and 0, 1, and 2. And those are just going to represent these colors. And that's part of the what makes the problem a little bit more complex is that they're just adding all these extra words. Okay. Now, there are a lot of ways of solving this. Now, the first one is you could just sort them, but it says you must solve this without using sort. And anyway, sorting is going to be n log n. Okay, so that's not going to be an optimal solution. We could probably do this in, O of n time. Now, O of n is a little bit deceiving. Okay, so you have one pass O of n, you have two pass O of n, you have, x pass of O of n. But O of n is still O of n when it comes down to it. Not really. But for instance, if this said just solve it in O of n time, or that was your interview question, and they said, I want you to challenge yourself and solve it in O of n time. Well, hey, we could do that. All right. Even if it's two passes, it's still O of n. Now, if they absolutely want a one pass solution, then you're going to have to dig a little bit. But for a two pass solution, we could do this very, very easily. So basically, the intuition is that we want all the zeros together, and then all the ones and all the twos, just sorting it in ascending order. So what we could do is go through the array, and let's go ahead and pick up an example. All right, and I'm going to go ahead and okay, so we have this array and we want to sort them. Okay, so what could we do? Well, one thing we could do is we could go ahead and say, well, I want to put these in, I just want to count the elements. Okay, so I'm going to count zeros, ones, and twos. Now, we could create some variables that say int c1, so count 1, is equal to 0. Int c2 is equal to 0. And then int c3 is equal to 0. Now, this screams, well, let's just use an array, okay? Especially since 0, 1, and 2 are natural indices within an array. Okay, so basically that's what we're going to do. All right, so what we want to do is we want to create that int array. And we'll just call it count is equal to, the new int with a size of 3. Okay, because we are guaranteed that there's only going to be 3 numbers. So this could be our count. Now, if they said there are going to be 9 numbers, well, 9 would be our count. If they said there's guaranteed to be, possibly 10,000 unique numbers, well, 10,000 would be our count. All right. And then what we're going to do is we're going to loop through nums, and we're going to say, well, do we have any, or we need to add a 2. And so to add a 2, all we would have to do is say count at num plus plus. All right. And basically that's the whole algorithm right there. Loop through the array, increase the count at that index. Okay. And then now, so that's a single pass, but that doesn't really get us to our solution. What we want to do is we want to take another single pass, and we're going to say, well, how many zeros do we have? So what is count at 0? What is that number, count at 0? And then we're just going to add them into our nums array. So count at 0 is going to be 2. And we're going to say, well, we have 2 zeros at count at 2. And so I'm just going to replace these 2 numbers with 0. And then there's no more zeros. And then I'm going to say, well, how many 1s do I have? Well, I have 2 1s. And so I'm going to replace these 2 numbers with 1s. And then I'm going to go to say, how many 2s do I have? Well, I have 2 2s. And so I'm going to replace these 2 with 2s. All right. And basically that's the whole algorithm. And here we don't have a return type. They're just going to evaluate nums as it is. And we're not really going to return it. Okay, so let's go ahead and look at this solution in code. Okay. And so, like I said, we're going to create that int array called counts. So int counts, and this is an array. So int counts is equal to new int and of size 3, because it's guaranteed we'll have 3 numbers. And then we're just going to loop through. So for int num, inside of nums, we're going to say counts at num plus plus. And then we're going to create this index. So int index is equal to 0. And then we're going to loop through our counts array. Okay. And to loop through our counts array, we only have 3 things in there. So, but it could be 10. All right. So, or 1,000. So we're just going to loop through our counts array. And so we're going to say int I is equal to 0, while I is less than, I guess we've already hard coded at this point. We could just say 3, or we could say a counts dot length, and then we're going to say I plus plus. And then what we're going to do is we're going to have a little while loop. Okay. Essentially, we're going through nums one pass. So 2 passes, 1 here and 1 here, or what's equivalent to 1 pass of nums here. So here, what we're going to do is we're going to say while counts at I is greater than 0, we're going to say nums at index plus plus. So we're going to advance the index after we do this, and we're going to say is equal to I. And I is the number that is represented at counts at I. Okay, counts at 0 may equal 6. Okay, that just means we have 6 zeros that we need to insert into the nums array. And once we've inserted a 0, we're going to say counts at I minus minus. Now we have 5 zeros to insert, and then 4, and then 3, and 2, and then 1. And then once it hits 0, it goes to the next number we need to add into our nums array. Okay, so we're going to run this code. and it is accepted. Let's go ahead and submit. And it says that it is 100% faster than 100%. Now, we could stop here, but this is 2 passes, and you may have an interviewer that says, well, can we do it in 1 pass? Because they're always trying to stretch you. You know, you do it how you do it, and you're like it's an elegant solution, and even if simplistic, and they're gonna say, well, let's do it even. Let's make it a little bit harder. See how you can think under pressure. Okay, but we don't want to think. We don't want to have to think under pressure. We want to. Well, yeah, you do want to think under pressure, but you want to have seen it before, so you don't have to think too hard. Okay, if you've seen something before, it makes it so much easier to use it in the future. If you've never seen it before, you don't even know if you can use it. You don't even know it's there to be used. So here we're going to use a 1-pass solution. Okay, so let's go ahead and get rid of this jazz right here. And so the whole idea of a 1-pass solution is to have pointers. Okay, so let me go ahead and get rid of all this stuff. Uh-oh. Well, let's see here. We'll just say new. And I'll just create the array up here. So we have 0, 2, 1, 2, 0, 1. All right. So what we want to do is we want to create 2 pointers. So we're going to point here. We're going to point here. And what we want to do is then loop through this. And so when we're looping through this, we're going to have our index. Okay, and so while we're looping through, basically any zeros that we find, we're going to place right here on pointer, on this left pointer, and then we're going to advance this. All right, and then any 2s we find, we're going to place on this right pointer, and we're going to advance this. And when those, so basically, when the index gets to pointer 2, we are done. All right, so that should be sorted at that point. Okay. So when we see a 0, so this is a 0 right here. We're going to look at it, and we're going to say, oh, I need to swap this with whatever is, so this is at index. We're looking at it at index. So this is at 0. And then this is at pointer left, which is 0. And it says, well, you know, if this index at 0 is equal to 0, then we're going to put it where pointer left is. And so pointer left may be a 2, it may be a 1, whatever. And so we're going to swap them. Okay. So that's basically the what we're going to do. We're just going to swap them, and then we're going to increase the pointer. We're going to advance the pointer by 1. And if this number were a 2, we're going to swap them, and we're going to take pointer 2, and we're going to subtract. Okay, so we're going to decrement here. Here we will increment after we swap. Now the index, if we encounter a 2, what we want to do is we want to keep the index the same. Okay, so how do we keep the index the same? What we're going to do is we're going to say, well, index minus minus, and then at the bottom we're going to say index plus plus to advance it no matter what. So in most conditions it's just going to advance, but when we encounter the 2 and swap, we're going to minus minus because we don't want to miss any numbers. Okay, there could be situations where edge cases where numbers get missed if we don't do this number or do this index minus minus. So we'll check that out, and we're going to see if we can get by without doing this, and then we'll see, well, maybe we do need that. Okay, so let's go ahead and code this one pass solution up. All right, so for this one pass solution, we're going to need three numbers. So int pointer 1 is equal to 0, is equal to nums.length minus 1. And then here we have our index, and that's going to be an int. Okay, and so what we're going to do is we want this to run until index is equal to or greater than P2. So while index is less than or equal to P2, what are we going to do? Well, we're going to check two things. We want to see if the number at index is equal to 0, because if it is, we need to swap it with the left. Okay, so if nums at nums at index is equal to 0, we're going to say nums at index is equal to nums at P1. And then, so this would be pointer 1. And this is pointer 2. Okay, so what we want to do now is we want to say nums at pointer 1 is equal to 0. Okay, so we know that a 0 is going to be here. And then we're going to say pointer 1 plus plus. We're going to advance that pointer so that the next time it's on the next number down. And then we're going to also see, so maybe this one, maybe nums at index isn't equal to 0. Maybe it's equal to 2. So we're going to say nums at index is equal to 2. All right, and then so if it's equal to 2, we're going to swap it again. So we're going to say nums at index is equal to nums at pointer 2. And then we're going to say nums at pointer 2 is equal to 2. Okay, and then we're going to say pointer 2 minus minus. We're going to go to the left, And then we're going to say index minus minus. And at the end over here, we're going to say index plus plus. We want the index to always be moving to the right unless the index at nums at index is equal to 2. Then we want it to stay the same, and we do that by decrementing here and incrementing here, which gives us a net of 0 movement. Okay, so let's go ahead and see what this does. Nums at index. Okay. If nums, well, index is less than or equal to pointer 2. Okay. If nums at index is equal to 0, okay, so one thing before we go ahead and submit is this index. I had misplaced this index plus plus down here. It was out of the scope of the loop, and we want this to be happening every time the loop advances. Okay, and so go ahead and put it within the while loop so that happens. Okay, so once we run this code and submit it, we get 100%. Okay, and you know that's pretty much in line with our last solution. But I think you know if we ran both of these 1 pass versus 2 passes, the 1 pass is going to win over. You know, on average, it's just there's so much variance with these numbers and leak code. Okay, so honestly, if I were in an interview and I didn't have to come up with the 2-pointer solution, and I could just say, hey, well, let's just do some an int array that stores the count. To me, that's the more intuitive solution. But you know, if the interviewer then says, well, hey, let's do it in 1 pass, then you've seen it before, and you know how to do it now. Okay. And if we took out this index minus minus like we said, and we ran the code, it might work for the first example, but the edge case where it actually skips a number, we're going to see that it fails. Okay, so we get the wrong answer, and it skipped the 1. Okay, so you definitely need that index minus minus there. Okay, and so that does it for sort colors. Like and subscribe. Otherwise, I will see you in the next video.